All right, team, this is example 21. Technically, it's the next exercise. Now, this can be really tricky for some because there's a lot of things here. There is the dilation factor of half from the y-axis, so it's a compression. Okay, so it's a compression horizontally. Then there's a vertical stretch to an amplitude of 3. Also, notice there is a translation moving to the right by pi on 4. And not only that, they also switched up the domain. So it's not 0 to 2 pi, it's not 0 to 4 pi. This is now pi on 4 to 5 pi on 4, which is, still technically it's a pi distance. It's still nice, it's just that it looks scary. Now, what do they want you to do? On separate axes, draw the graphs of the following functions. Use a calculator to help establish the shape. Don't. I'm going to teach you how to do this by hand, and I'm going to teach you what we call the quarter cycles. Okay, so what do I mean by quarter cycles? When you're sketching sine and cosine, I want you to, this is probably the next challenge after learning how to solve equations, is to know that in a unit circle, there are 4 main angles that you need to focus on. So you notice that it is the 90-degree point, so pi on 2. There is the 180-degree point, which is pi. There is the 270-degree point, which is 3 pi on 2. And then finally 360 degrees, which is 2 pi. Okay, so there are 4 main angles, 1, 2, 3, and 4. This is what we call the quarter cycles. So you're going to split this graph, no matter what graph you ever get from here on for circular functions, you're going to split it into 4 sections. So this is when this cycle has a period of 2 pi. Okay, so if the period is 2 pi, those are your 4 main angles. But in your case here, the period may change depending on what the dilation factors are. In our case, notice our period is affected by that 2. So our period is no longer 2 pi, it is the reciprocal of 2, so 2 pi times the reciprocal of 2, which is half, and that gives us pi. So I now know that one cycle, it is pi, okay? That changes everything. That means this now is pi over 2 to make it halfway. So from here to here is pi on 2, to here again is pi now. Then that means this changes it to pi on 4, and this is 3 pi on 4. Okay, so we're focused now on quarter cycles. So how I normally teach the students is that you find out the period first and then quarter cycle. So QC, if you want, quarter cycle is P divided by 4. It's pi and 4. Okay, so from here to here is pi and 4. That's essentially what I'm trying to work with. So quarter cycles are pi and 4. Now, why is this important to know your quarter cycles? Because the quarter cycles is like it's going to help you to get to know how to get from one point to the next point, because it's in 4 parts, right? Once you know how to get from one quadrant to the next, then you know how to do it for them all. So this is how it's going to work. We know quarter cycles pi and 4, but how long does it take to get from one point to the next point, right? We knew it was pi and 4 distance, but where are we starting? So let's read the graph here. We've got a maximum amplitude of 3, so -3 amplitude. We've got a period which normally is now pi. It's a sine graph with no reflection. So we know that the graph can look something like this right now, okay? But notice that there is a movement. This minus pi on 4 actually moves it to the right by pi on 4, okay? So it moves to the right by pi on 4. So this starting point, you only need a starting point, all right? Starting point was at 0, 0. Now it's moved to the right by pi on 4. So this point now has moved to the right by pi on 4, and we're going to use that. We're going to use this key point here, this lovely point here. That's where we're going to start, okay? So pi on 4. To get to the next quarter cycle, okay, so to get to the next quarter, so starting at pi on 4, I know that I need to go a distance of pi on 4. I know this is confusing because we're starting at pi on 4 and we're also, the quarter period or the quarter cycle is pi on 4 as well. So what I'm trying to say is you started off at pi on 4, that's a starting point. So do SP for starting point. We know that to get to the next quarter, so to get to the next quarter, because remember the graph, the sine graph is broken up into quarters. Think about it. To get to the next quarter, this is the next quarter, you'll reach the maximum. The next quarter, you reach the center. The next quarter, you reach the minimum. The next quarter, you reach the center again. That's the pattern. So you're trying to figure out how long does it take to reach the maximum. That's what you're trying to figure out. That's the first quarter. So we knew that it's the quarter cycle is pi on 4. So I need to add an extra pi on 4 to get there. So pi on 4 plus pi on 4 now gives me 2 pi on 4, which makes it pi on 2, right? But I want you to keep it in pi on 4s right now, okay? So pi on 4 plus pi on 4 is essentially 2 pi on 4, okay? So that means I'm going to write here, this is now 2 pi on 4 to get there. So how much did I actually have to add? I added 1 pi on 4 to get to that next quarter cycle. So from 1 pi on 4, I add an extra 1 pi on 4. Then to get to the next quarter cycle, now we know the pattern is an extra 1 pi on 4. So I'm going to add another one. That now gives me 3 pi on 4. True? Okay, so now this is the pattern I'm going to follow. So the pattern was, remember, center, maximum, center, minimum, center, maximum, center, minimum. That's what the sine graph does. Yeah? So if that's every quarter cycle, I can actually sketch this out now. See, I can kind of picture what the graph will look like. I'm going to do it again. So I'm going to draw the axes. Here we go. We started off at pi on 4. We knew that the next quarter cycle, okay, the next quarter cycle, knowing that a maximum of 3, minimum of -3, we knew that it reaches the maximum point at 2 pi on 4. Then the next quarter cycle, okay, so the next quarter cycle, it reaches to the point of 3 pi on 4, because there's an extra one. So 3 pi on 4, it reaches its minimum, which is down here. True? So, oh no, not the minimum. So center. So it reaches center at 3 pi on 4. And then I follow the same quarter cycle again. Remember, when you're actually doing this, don't do these dotted lines, or you can and then rub it out, okay? I'm just doing it so that you can see. So here we go, next quarter cycle has to bring us to the minimum. Yeah, so maximum, center, minimum, and then center, and then maximum, and then center, and then minimum, and this pattern just keeps going. And it's the same thing for this side as well. So if you go backwards, it was maximum, center, then next one has to be minimum. But you know you're going back, the next quarter cycle has to be minus pi on 4, which conveniently brings you to 0. So that's why I know the point is here. Can you see that? And then you can go all the way to the next quarter cycle is negative pi on 4. That brings you to the center. Next quarter cycle is another pi on 4, so negative 2 pi on 4 brings you to the maximum. Do you see what I'm doing? Can you see how I'm going maximum, center, minimum, center, maximum, center, minimum, center, maximum, center, minimum, center. Can you see what I'm doing? And each one is just a quarter cycle. And the quarter cycles are easy to predict because it goes from, we worked it out just now that we knew you're adding an extra pi on 4. If we follow in terms of the pi on 4 distances, this is now 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, and then 7 pi on 4, and then this last one is 8 pi on 4. Can you see what I'm doing? So if you do that, can you see that now it's easier to figure out the domain? The domain was going from pi on 4 to 5 pi on 4. So which ones do I want? I only want pi on 4, which is here, and where's 5 pi on 4? Over here. So the only parts of the graph that you needed was only this section. See that? That's all you need. So if I rub everything out right now, if I rubbed all those dotted lines to see what I did, it also helps you graph it nicely as well because it's all in proportion. You see, like if I just rub all this out right now, there we go. This is my nice, perfect graph. This is why back then they've removed the fact that students have to sketch circular functions in exams, is because it takes too long to do. You see what I'm doing? And now you just need to solve. So really, you don't need this part here. There you go. That's my graph from pi on 4 to 5 pi on 4. And that gives me, it happens to give me a nice full graph that actually goes a nice period of pi. From pi on 4 all the way to 5 pi on 4 is actually a period of pi, which remember, we said the period was pi. That's why it works out nicely. So this question that I just did, this is actually a nice problem. Usually when you start doing the harder questions, it may end up being that you start here and then you finish here as an example, right? So it doesn't have to look this nice. The question that I've given, that's given here is actually a nice question and it looks nice. Okay, but the main part is to understand the purpose of finding the quarter cycle. Because once you know how long it takes to reach 1/4, then you can predict the rest. And you can put in the dot points up until, you get to wherever you need to. And that's how you solve it. Okay, so I'm going to do now another example. I know it took me 10 minutes to do that explanation there for you to get. But I'm going to try to do it again for part B, so bear with me. It's the same idea. You can pause it and then have a go with part B if you like. It's the same concept. All right. This one is also another nice one. Notice that they move by pi and 3, and then they also give you a domain that seems to work between pi and 3. So they are trying to help you out in this question. It looks nasty. It's not. Okay. It's only nasty when it doesn't fit the domain and you got to make it work with the domain. That's when it's tricky. That's for 14J onwards. Okay. So for right now, that's what I want you to work on. It's tricky. But in terms of the x-intercepts, you notice that I didn't even have to find them because as I'm drawing it out, it turns out I already have the x-intercepts. Hard ones are when you actually have to solve it using what you've learned previously, how to solve axis intercepts. That's when it's tricky. Okay, let's do B now. Let's do B. Okay, I'm going to do B. I'm going to write it down first just so I can see the question. So B is y is equal to 2 times cos of 3 times t plus pi on 3. That's it. Yep. And then the domain is from negative pi on 3, where t is smaller than or greater than and less than pi on 3. Okay, cool. So same thing again. Let's read what they've given us. Okay, they've given us 2, so that's amplitude. Vertical stretch 2. Period changes now. Okay, period is 2 pi times. Now, the reciprocal 3 is a third, so I know that the period now is 2 pi on 3. This tells me that I'm moving to the left pi on 3. This is a cos graph. So when I draw this, I'm going to try to visualize what it normally looks like. So normally a cos graph looks like this, starting off at the maximum. True? But now I know that it shifted the graph. The starting point is here. This is the starting point, yeah? The starting point now has moved to the left by pi on 3. So think of it as you've moved to the left by pi on 3. And so the starting point is now here. That's your new starting point. Okay, so that's what I want you to start. You always need a starting point. So this is the starting point. I do SP for starting point. So that is at the maximum, which we know the amplitude is 2. So at negative pi on 3, it's at the maximum at the moment. Okay. All right, now let's work out the quarter cycle. So we need to work out the quarter cycle. So quarter cycle, I'm going to give QC is 2 pi on 3. And remember, you divide it by 4 to find that quarter because the period is 1 full length. That's how long it takes to get there, right? Or cos graph looks like this. That's how long it takes, 2 pi, but I only need a quarter. I need to know this is the half, and then you've got your, that's your maximum. So the next one is, that's a quarter, that's 3/4. I need to know how long it takes to get to the center. So maximum, center, minimum, center, maximum again. See what I'm doing? So I'm trying to find how long it takes to get to the center. How long does it take? Because once I know how long it takes, I can then add it on to get to the minimum, add it on again to get to the center, add it on again to get to the maximum. That's the idea of finding quarter cycles. Okay? So I'll delete all this so it doesn't confuse you. All right. Quarter cycle, 2 pi on 3 divided by 4. So I'm making it into quarters now. And that gives me a nice, 2 pi divided by 4 gives me pi on 6. Or if you don't know how to do this, I'm going to write it again. 2 pi on 3 times 1/4. And you can see that the 2's and the 4, that reduces the 1 to 2. And that's how I got pi on 6. Okay? So that means that to get to the next quarter cycle, so starting from this point, this is the point, I need to add pi on 6. Okay? Now, notice that I'm starting off at negative pi on 3. So what I like to do is I like to convert this pi on 3. So let's think about it. I started off at pi on 3. I'm going to write it again. Negative pi on 3. I know I'm adding an extra pi on 6. True? Now, when you're adding an extra pi on 6, to add fractions, you need the denominators to be the same. So I need to convert this to times by 2, times this by 2. So this negative pi on 3 is the same thing as negative 2 pi on 6. See what I'm doing? So this is special. Why? Because now I know the starting point is at negative 2 pi on 6, and all I have to add on is an extra 1. 1 pi on 6 to get to the next quarter cycle. So right immediately from this graph, I already know that the next quarter cycle is you adding an extra 1 pi on 6, which lands you at negative pi on 6. See what I'm doing? So now if I drew the axes, if I just drew it out for you to see, I know I'm going to rub all this out just so you can picture it. I'm saying that your next quarter cycle to take you to the center is at pi on 6. So then it goes down to the minimum, must be another extra pi on 6, which means 0. To get to the next quarter cycle, it must be then an extra 1 pi on 6. So then this brings me to the center. Then to get to the maximum again, so maximum again, that means it has to go an extra pi on 6. Oh, sorry, 2 pi on 6. And then 3 pi on 6. And then 4 pi on 6. And then 5 pi on 6. Can you see what I'm doing? I'm just following the quarter cycle. So it goes maximum, center, minimum, center. This is what my cost graph would look like. That's 1 cycle, 2 cycles. Oh, sorry. I should be like this. 2 cycles. Okay, and then next one is 6 pi on 6. So this is what I do when I teach quarter cycles. Can you see? It makes it really easy to sketch the graph. So this is when, once you now know, okay, I need to start up negative 2 pi on 6, and I know I'm only adding an extra pi on 6 every time. Now when I sketch it, you see, I'm working from negative pi on 3 to pi on 3. If you convert that into pi's on 6s, so times this by 2, times this by 2, times this by 2, times this by 2, you know you're working from negative 2 pi on 6. I'll write it again just to help you. I'm working from negative 2 pi on 6 all the way to 2 pi on 6. And that's really easy because look at it. I know where negative 2 pi on 6 and 2 pi on 6 is. It literally is here. Negative 2 pi on 6, carry all the way through to 2 pi on 6. Look at that. Okay, so if I were to really put it all nicely into a graph, can you see how easy it is once you had your quarter cycles? See, all I have to do now, so I'm just going to draw it properly now. Okay, we figured out before our starting point was negative 2 pi on 6. True? And we knew that was at the maximum. So the maximum, what was the maximum again? Amplitude was 3, wasn't it? No, 2. Sorry, amplitude was 2. So amplitude was 2. So I know, okay, so that's 2. That's the maximum. So the minimum must be then negative 2. Now, the pattern goes maximum. The next quarter cycle brings you to the center. But we knew the distance was an extra pi on 6. So that lands us at pi on 6. So this is my next point. So that's my next one. I'm just going to cover over it. Oh no, what's happening? All right, there we go. I'm going to cover over it. So that's center. Then the next one is minimum. Okay, so next quarter cycle brings us to now 0. So next quarter cycle, pi on 6, so negative pi on 6 plus pi on 6 gives you 0. So I now know the center, the minimum is at 0. Okay, and then the next one is at another pi on 6. So that gives me 1 pi on 6. Next one is 2 pi on 6. Next one is 3 pi on 6 onwards, right? But remember, the domain they gave us was from negative 2 pi on 6 to 2 pi on 6. So that means if I follow the pattern, it was maximum, center, minimum, center, maximum. So if you were to sketch this graph now, it's really nice. Once you've got all the dots there, it's really easy, isn't it? There you go. And it's also perfect as well. Looks nice and perfect, and it is within the domain of negative pi on 3 to pi on 3. That's what it is. See what I'm doing? So that's how you would sketch this graph with the correct amplitude, with the correct period, and we can see that the period was 2 pi on 3. Is that actually 2 pi on 3? That's weird. Negative 2 pi on 6. Negative 2 pi on 6 plus 2 pi on 3 is the same thing as adding 4 pi on 6. And oh, yep, no, that's good. Cool. I just felt like it felt interesting. But yes, the period is 2 pi on 3. So it works. So starting from negative 2 pi on 6, if you add 2 pi on 3, you'll end up at 2 pi on 6. Okay? But there you go. So you got the correct period, you got the correct amplitude, and you happen to have the exact 1 cycle because they gave you the correct domain for that. Okay, so that wasn't an accident. They gave you a nice graph. Okay, normally that's not the case. Normally it doesn't have to be a nice full cycle. It can stop and start anywhere. Okay, but I hope you see the benefit of doing this quarter cycle, because once you understand this and you go into 14J, it is exactly the same. All the techniques are exactly the same, The only difference is you do have to add on an extra technique where you find the x-intercepts. In our case, it just so happens the x-intercepts were nice and easy. Okay, we already have them. In the next exercise from this, when you upgrade a bit, or go into the next skill, you have to find the x-intercepts. Okay, and that's the only difference. Okay, if you move it up and down, it only changes the amplitude. That's all it does. Instead of, say, if I move the graph up by 1, instead of 2, it's now 3. Instead of -2, it is now -1. That's the only difference. Okay, and obviously the x-intercepts will change if you shift it up. And that's why you have to calculate the x-intercept. So that's the next challenge. But this one, to me, right now, if you can understand how to use the quarter cycle, you are so ahead of a lot of students when it comes to sketching circular functions. And you do it again in year 12. Okay, so really watch this video again. I know it's a long one. It's 20 minutes so far, 10 minutes on each one. But I really want you to see the benefit of using quarter cycle.